So let's look at a few things that you will need for the next lab. We have right here our circuit, and I see there's an error in RC. If you noticed, the values in the lab were different than the values that I put in. So you were supposed to follow the values in your lab. Also, we do not need this voltmeter, so we will delete it. And we also do not need the milliamp, the amp meter either. So we're going to reconnect the circuit, and here we go. What we need to do is we need to put a capacitor. So for the capacitor, we usually want to use the capacitor active. We're actually going to see how it works, and it's nice to see it. So again, we want to place the capacitor. Like in the lab, we want to change its value to 1 microfarad, not 1,000. We can leave the name of C1, it doesn't matter. We're gonna add a wire sticking out because this is where we want to plug in our V in. So our voltage that we're gonna be amplifying. As well, what we want to do here is we want to observe what's going on. So in order to observe what's going on, we need an oscilloscope. So we go to the tools right here, and we have the oscilloscope. So if we pick the oscilloscope, which is it's highlighted, and then we place it on. One thing you have to know is that your ground that you would usually use on each probe, on this oscilloscope, for the simplicity of wiring, the ground is already connected to the ground, so you don't need to worry about it. All you need to do is take channel A and bring it to exactly where you want to have it connected. So I want to connect channel 1 to my input. And in the lab, if you look well, your output will be at VC. Actually, it's not written in the lab, but your output is at VC. So you take B, and it doesn't really want to go exactly where I want. It does that sometimes. So you can just click where you want to force it, and then bring it in to exactly where you want. So this is awesome. Now we're going to add the sine wave. So here you have a generator mode. So you can choose whatever form that you want. So we'll choose the sine wave because that's what is asked. And we have it right here, and we're going to place it. Notice I'm going to zoom in. Notice that when you place it, that little reddish square means that you're placing it on the wire, so it's connected to the wire. When you double click it, you can rename it V in, and you can fill out the different values that are required in the lab. So over here, you want to keep in mind that when we talk about voltage peak to peak, in this software, amplitude is actually the peak to peak voltage. So 1 volt is what is asked in the lab. And what is asked also, it's a frequency of 100 hertz. So, and you don't have to do anything else. It's a sine wave, the amplitude, the frequency. We don't want any offset and we don't want any phase. So we press OK, and then we zoom out a little bit if we want. And we're going to recenter. And one way of recentering, I don't think I have shown you this before, but it's to go here in the upper left corner. And if you click once, you can move around the screen anywhere. And you click again and you have recentered. You can also use your trackball and you zoom in. And depending on where your mouse is, it zooms in, centering on your mouse. So let's start the simulation to see how the oscilloscope works. So for the oscilloscope, you get a beautiful little pop-up that has 4 channels with 4 different colors. You can turn them on, you can turn them each one off. So since we're only using channel A and channel B, let's turn off channel C and channel D, since we don't need them. You have here the rotary, the same way you had on the oscilloscope at school, that defines how many volts per division. We know that we asked for 1 volt peak to peak. So that's over here. Actually, as you see, we're getting more like 2 volts peak to peak. So the amplitude, so it's not correct. So what I said before wasn't correct. The amplitude is the peak voltage. So if we wanted a 1 volt peak to peak, we have to stop the simulation and go back right here, double click. We want peak to peak to be 1 volt. So we have to have an amplitude of 0.5 volts. And I'm pretty sure that we need to put 0.5. Okay, let's start the simulation again. And this time we're getting exactly what we want, a 1 volt peak to peak. So here what we want to do, remember, when you want to measure something, you want the image to be as big as possible on your screen in order to measure accurately. Since this is a simulation, there's no question that the measurement will be good. There is no possible error. But in order to see it better, you want to have a higher amplitude. So I've put this one at 0.2 per division. So I'm going to see it bigger. I'm going to put that's the output, and I'm going to put the input also at 0.2 volts per division. And all of a sudden we can see that the input wave is smaller than the output wave. And we're going to move it around. So with this dial, we can change the position and move it up or down. So we can bring it down, let's say to 20, and we can bring this one to 20 also, not minus 20, but 20. It's a little hard to get it exactly on the 20. There you go. And in order to see it a little bit better, I'm going to want to expand on the time. There you go. So I have the input wave in yellow and the output wave in blue. And I can see that the input wave is smaller than the output wave. And I can take all the measurements and I can do all the work that I need to do. A few things about the simulation and the environment in general. So about the Proteus is that if you decide, okay, I don't want to see this simulation anymore. I don't want to see the oscilloscope anymore. So let me close the window of the oscilloscope and let me make some changes. So I'm going to stop the simulation, right? You can't, you cannot do any changes on the simulation, on the schematic if your simulation is running. So let's say here, one of the things it says is increase the amplitude until you get distortion. So I'm going to pump it up quite a bit, but you can pump it up gradually. And I'm going to press play again. Wait a minute, my oscilloscope is not there. Because you closed the window, it closed it, not forever, but it did close it more permanently. So in order to get your simulation back, the simulation of the oscilloscope, you have to go into Tool. No, it's not Tool. It's in Debug. I'm sorry. You have to go into Debug and get your digital oscilloscope to come up. Wow, this is so much bigger. Don't forget, we put 3 volts peak. So I'm going to put it at 1 volt and 1 volt. And here it goes. It's much bigger, but I still don't have any distortion. One trick, if you don't want to lose your oscilloscope, is you don't have to close this window. You can just stop the simulation and the oscilloscope window goes away. The fun thing about doing that is that if now you increase your waveform and you start the simulation again, the oscilloscope screen comes back. So if you don't manually close the oscilloscope screen, you just stop the simulation, the oscilloscope closes and starts back. And all of a sudden, you find that now you have distortion. So if you were wondering what distortion is, this is it. These little weird looking sine waves, that is distortion. So you want to find the point where distortion just starts and you want to find that, and you want to find out why. That's up to you. I'm not going to tell you how to do that. So